We're going to take a look at a few examples on how to work with imaginary numbers. Again, if you see a negative underneath a square root, the best way to treat that is to go ahead and remove the square root of -1, and then just simplify the radical as you typically do, and then we're just going to reassign -1 as I. That way we can follow the other conventions and other operations as we do in algebra. And so the one last thing we probably want to look at is in this case, since it's 6 times the square root of 5 times I, typically we put the I unit in front of the square root so that it doesn't look like it's underneath the square root, that it's its own value. So when we're multiplying, especially multiplying with imaginary numbers, we just want to, again, it's best to separate out the square root of -1, so we can treat that as I, the I unit, and then go ahead and simplify as we've done before with radicals. And so again, thinking about square roots and what can be factored out of square roots is a good strategy for that. And then we kind of just arrange things in terms of their values. So the rational numbers that we can multiply together, and then square roots. And then we can think about, in this case, we've got I times I, which is I squared. And remember that that unit, I squared, is equal to -1. So that's the two conventions that we have, is that we use I to replace the square root of -1. And then I squared, we say, is equal to -1. And so then this will equal just the negative 240 times the square root of 7. So key ideas, again, -1 is replaced with I, and then also the convention I squared is equal to -1. Again, in this product, we'll go ahead and simplify the square roots, and again remove the square root of -1 so that we can continue to simplify those, and then just replace the square root of -1 with I. And then we again multiply any of the rational numbers together, and then multiply that by the irrational. And then again, remember that we tuck that I in front of the square root of 10, and that's just a convention that we use with imaginary numbers. So where imaginary numbers appear, that we'll see them here in this instance is quadratics and the quadratic formula. Here's an example of that, when we really, instead of trying to take the square root of 196, go ahead and treat that as 196 times the square root of -1. And so then we can go ahead and then simplify it, so 16I, and when we divide both of those parts by 2, it will simplify to what we refer to as a complex number, where it's the rational part and then the real part and then the imaginary part that goes with that. So then from beginning to end, with a quadratic equation already given in standard form, we can use the quadratic formula, and with A, B, and C identified, we can go ahead and write and plug in the numbers to the quadratic formula. And when we do this, you'll see in this particular problem we end up with the square root of 4 squared minus 148, which ends up giving us the square root of -144. So typically, again, we're going to want to treat that as an imaginary number. And because when we separate that into the I term or the I unit, we can then write that as 12I, and then go ahead and divide both parts by 2 since it's over 2, and then we can write it in complex form, which we would have -1 plus or minus 6I. So that A plus B form, or A plus BI form, is the complex number. form. So again, this one's already in standard form. So when we use the quadratic formula, we will end up with the square root of 64 minus 80. And again, notice that's going to be a negative number, so we can treat it as using the imaginary unit. And we get square root of negative 16, which again, we treat as a rational and then the imaginary unit, so that those properties, we can still continue with the same operations. And once we have the square root simplified as an imaginary unit, we can then just divide both parts by 2, the real part and the imaginary part, and then we can write it as the complex number. And again, even though it's a plus bi, this is both plus or minus those two.